So, you're all very welcome, and thanks for tuning in. So, where will I start? I decided to, start a channel on rare Formula One parts, or parts that would never be seen in the general public. There's a few very rare parts in the newer engines which have never seen the light of day or were very highly guarded, through the years. Now, I've written a lot online about various Formula One parts. Some of you may know me. It's Brian G of F1 Technical mainly, I guess. I've written a lot of articles on various Formula One parts. Now these parts have been obtained legally and all that. They're not, off the back of a van or anything like that. They're all legit, and they're all mine. So I guess I wanted to put a bit of scale to things and a bit of reality to the writings I've been doing over the few years. I think my first piece was done on, oh geez, what was it? I think it was a Formula One wishbone back about 7 years ago. But I guess what spurred it in the real early days was the Volkswagen scene. I did a lot of work with 16 valve cylinder heads and all that. I did a lot of publishing on forums as well of what you could port them to and what you could bring them out to and all that. And so I've been around engines since I was a kid. So I'll break it into steps, I guess. I may pause it here and there, but let's talk you through what's it going to be about and all that. So, as you know, in a normal engine, just to say, first of all, a bit of an introduction, I guess, because there may be, 10 or 20 videos similar to this. I started off life as a cabinet maker. I branched out then into making patterns for casting, and I got into casting in a big way, because the cabinet making skills directly relate to casting, because you need patterns which are fairly well made in order to make the sand molds. So I sprung into, well, I was always engineering background, but the engineering came stronger then because I actually started designing the parts I was casting and not actually casting them then. So it kind of went from there. My day job as well is, I guess, a designer involved in high level R&D and all that globally. So I have a fair idea of what's involved in making things, or what parts are about, or what to tell you guys about, parts of interest and all that. So look, it's going to be an interesting journey, and we'll have a good chat about everything. So in a normal engine, the valve is controlled with the camshaft, and it is returned with a spring. Now that's fine in a normal engine because the RPM is fairly low, but in a Formula One engine, what happens is if you use a spring or springs, you can sometimes put them coaxially, you can stack them. They'll reach a certain point in terms of hertz, in terms of RPM, and at a certain point they just won't function after that. They'll start bouncing and they'll do all sorts of things, and eventually they'll fracture and they'll break, which is bad because your valve no longer returns and your piston then will hit the valve. Now in Formula One, in about, I think, what was it? I think it was Renault that brought it in first in about 1987. I'm not going to go into dates on this channel. That's one thing you should be aware of. I'm not up to speed on dates in Formula One. I just know the tech. Drivers, I have no idea. Again, I'm not going to go into sizes and all that. If people want sizes, I'm not going down that road because it's pointless in ways, Again, with all sorts of stats on oil pressures and all that, if you want to know all those, just look them up. Switch off now. It's not going to be on this video. This video is going to concentrate solely on the core mechanism and what it looks like, what it does, what happens, why it needs to be there. Again, this is an extremely rare part. I don't think it's ever been shown in a video before, so it's enough to discuss that alone. So in a Formula One engine, as I said, in the late 80s, they ditched the springs and they came up with a pneumatic return system. Now, this item here is a Cosworth item. And the Cosworth item is called the PVRS, which stands for Pneumatic Valve Return System. So it's, in terms of many of the Honda guys watching this will recognize that it's got a finger follower. Now the Volkswagen guys, or the BMW guys, the later or the earlier BMWs and Volkswagens had a hydraulic tappet or solid tappets. Even going back to the early Golf GTIs had solid tappets, but they were all basically bucket tappets. But the Honda guys will recognize this. You can see it's very similar. It's a finger follower, and your normal camshaft and your normal valve, all that. Your shim on the top of the valve as well, the lash cap. That's all the same. So that's going to be familiar, and the head of the valve, of course. So that's all going to be familiar to many people watching this. Now, just to explain what this jig is, this is a jig I obtained nearly all of a TJ V10 Cosworth engine, and I've measured the entire engine and brought it into CAD in nearly every single piece. It took, I guess, 5,000 hours nearly. So what I did was I took a small bit of the CAD and I replicated it in a test jig, if you want. Now this test jig has been put together just quickly for the video. You can see the caps and all that. It's been line bored. There's a window here for sensors to measure the valve because I want to do some tests. The oil supply is right here on this banjo fitting. You can see it here. So that banjo goes in. There's two drillings across here, in here, into the camshaft. The camshaft is the exact Cosworth item. It's hollow, as you can see, for lightness, and it's got the DLC coating, the diamond coating, for wear, and so is the finger follower, in fact. So this is a test jig, as mentioned. It replicates the cylinder head exactly, and it just saves, the cylinder head is an awkward thing because you can't see different things and all that, and it's just hard to see it. So I'll discuss the how it's laid out first, and then I'll maybe pause the video for a bit, take it all apart, and then show you the item of interest. So it's fairly straightforward. The camshaft, as mentioned, is hollow. It drives the finger follower. Nothing new there. The finger follower presses down the valve, but in here is a little air chamber, and it's like a pneumatic ram. And here is the piston. You can just see it there, which is also the I guess what you'd call it, the retainer, in normal car speak, and the two valve collets are there on top. So that's all fairly standard. Again, the valve is nothing special, standard, made by Del West. They were a US company. Actually, I approached, when was it? About 7 years ago, I think, or 8 years ago when I started. I got a big interest in this because they're phenomenal bits of kit. The speeds and all that, and the stiction and the friction and everything they have to overcome, the sealing and all that. It got me really interested. So I had to find out how they worked. So I remember contacting Del West about, I guess it was 7 or 8 years ago, that could I buy just one assembly, but obviously that was a non-runner. They barely answered my email. I contacted a few companies in the UK, and I was basically told that you have no interest in, you don't need to be buying them, we're not going to talk to you. So I eventually acquired one anyway. After a lot of searching, I met a very nice man, which I won't name, in a company in the UK. I may name him later, but I have to speak to him first because we became pretty close since. So I'll see if he wants to be mentioned or not, but he was able to get me one. Now this item is out of a CA, the Cosworth CA, the Cosworth V8, the last one of the V8s, which I think revved to, I think on the test bench it was tested to, I could be wrong, 19,000 to 20,000 RPM. So that's going pretty quick. Now the camshaft and all that, this jig is designed around the TJ, which is the V10 Cosworth. So there's a small bit of differences here that you'll notice if I turn the cam around, you'll notice the valve is shorter. And the reason that is because the TJ had what I'd call a T-shaped or an I-beam head, where both camshafts were mounted on like an I-beam, whereas the CA, the later CA, they went away from that and they went with the conventional head. Now, in fact, it was a bit like the DFV head in ways, because it was a multi-layer head where the finger follower carrier and all that went on separate, because you could get at the head bolts were underneath the line of the cams, so you couldn't, it had to be multi-layer. So it was unusual in a way, because every interface you have is a weakness, and you've got tolerance stack up machine and all that. But that's what they did, and it was a smashing engine, so who am I to comment? But so just before I pause you guys and strip this down, air comes in here on a gallery along the head. So I've got a banjo fitting here with a braided line off it. Air comes in here, it enters the chamber here and pressurizes the air pressure underneath here. Now it's many bars, it's really high air pressure to keep the valve on its seat. And it, you can see if I turn it this way, there's a little, if you can see that there, that's where all the non-return valve is, and there, and where it can blast off the air. If the problem with these is, it was a huge problem at the start. These, obviously, because they have seals here, oil can get past the seal, and what happens then is the chamber itself can fill up with oil underneath the piston, which will raise the pressure, or worst case, if it was full up all the way, it just wouldn't be able to close, So they have a clever bit of valving in here that can blow off the oil if it needs to, if it senses that there's too much oil in it. It's all done remotely. There's a full, like a ring main of airways in the engine. Now it's only one supply. Some of the others had two supplies and crazy dump systems and all that, but they were troublesome, in the early days when the seals would fail. I'm sure you've seen it back, oh geez, I guess 95 or 1995. You'd often see a car engine just exploding, or a load of smoke on the track afterwards, and the driver would have to pull in. It was nearly always the pneumatic valve train that failed, just because it was so early. The sealing was early days, the technology was very new, so it was a huge hurdle to cross, because again the speed here is crazy, and you've got 13, 14, 15 mil lift as well, so it's beyond insane, which is why I got it so excited about it initially. So just to do a last talk on it before I split it apart. This is a modular system. Now, some of the earlier cylinder heads, they had this actually cast in to the cylinder head, and I guess the plunger and piston and all that would slide in the actual cylinder head. But that was kind of back then, and with casting thicknesses and all that, it ended up pretty heavy by the time you've a 3 or 4 mil wall around all that, in terms of cast aluminium. Let's say whatever it was, LM25, or as the Americans have called 365 or 356. So it ended up very bulky, and there was also, I guess, porosity issues in the casting as well, that if you did all these complex drillings and all that in the casting, you could run into serious difficulty if the casting was porous, and you'd start leaking air that way too. So the modular system kind of got around all that. It made in-head machining, I would say, on a CNC machine a lot simpler. They were all just modular units, and they could be replaced. You didn't have to bin the head either, even though the heads were binned after 1,000 kilometers, let's say. But you could identify an issue. It was modular. You could just go in there, take it out and all that, and it wasn't a pain to machine. It was just deck it flat and bolt them in. So what I'm going to do now is I'm going to pause it, and I'm going to strip this, and we'll get out what we need to see. We'll have a proper look at it. So I'll talk to you in a moment. So here we are back again. Now I said I stripped off the jig, the test jig I'd made. So this is the unit in question. So this is the mock cylinder head here, and this is the air supply, as I said. That's just in there with a banjo fit and a drilling down. So it's pretty compact, as you can see. It's pretty tiny. So it's, as I said, standard valve, standard lash cap. These would be ground. They'd be set, the valve off the seat. They'd be checked with feeler gauges, the crack, and they'd be ground then to match each one. Now, actually, having said that, I'm not 100% sure if they ground the tip of the valve or the lash cap, but anyway, it's irrelevant. Now the lash cap snaps on. There's a tiny little, I don't know if you can see that, probably not. There's a tiny little wire lock in there and it just snaps on. Once it's in place and this is pressurized, it can't go anywhere, you know. So that's that. Now I just want to speak about the finger follower for a moment before I move on to that and take apart that. The finger followers are hung from the cylinder head on an axle. I have one here that's already removed. So you can see it there. It's a standard enough, you know. Now the intake and exhaust finger followers are different lengths, so it rides on a. There's no needle bearing or anything like that. It just rides on a shaft like so, that's bolted into a pocket on the cylinder head, which I'll show you now. You should see it there. There's very slight flats just there to let the oil in. The oil can go in past. There's a very slight space there with the flat, and the oil can go in and it can collect here, and it oils all that. So that's how that's lubricated. Again, in terms of axial thrust this way, there's very slight divots there, which you can probably see on the light, which lets in the oil to face. But again, there's no side thrust really on these, you know. Unlike, you know, a tappet where the cam would be offset, you know, to rotate the tappet. These are directly in line. So they're a nice item, you know. And again, DLC coating. You can probably see the TJ stamp there, perhaps. Maybe not. So that's that part, you know. Beautiful geometry, you know. Mind-bending geometry with camshaft design and finger followers and all that. Because again, the acceleration rates, you know, the rate the valve is accelerated off the seat is mind-bending in Formula 1 engine, because there's so little time and you want to get it open as quickly as possible. And again, once it's closing, you can't just let it slam onto the seat, you know. It has to close very, very carefully, you know, otherwise you'll just rip the head off the valve. So that's the finger follower. Now, one last thing with these, which you'll see on the head as well in an image. These are oiled with oil jets. Now, the oil jet would be similar to this. It threads into a bore in the cylinder head. You can see a very small hole there, and the oil jet threads in there, and it's angled at the interface between the cam and the top of the finger follower to keep a decent amount of oil there. Now, on an earlier cylinder head, which I found, initially at the start of all this, I was searching for pneumatic systems, and I found one. I was emailing literally everyone in the world, and I found one in Donington. So I flew to Donington and I found a Brian Hart engine. You probably remember those. It was a V10 as well, but the Brian Hart engine was quite old-fashioned. Actually, I have a section of cylinder head here from it. The Brian Hart engine had tappets like a normal engine, you know. It had no finger followers. Again, you can see the oilers here. They're bonded in right here with the, it's probably Araldite from that age, and it aimed at the top, at the interface there, at the top of the tappet. Now, the chambers in these, this was also a pneumatic valve train, but the chambers in these, the system, I guess the cylinder system in these, was an aluminium barrel that sat here, bolted down here, and the plunger, the piston plunger actually ran on the wall of the aluminium. It had a PTFE impregnated anodized coating inside, and it was honed to a high finish, but it actually ran against the aluminium. Now, I believe, I'm told from, you know, mechanics and friends of Brian Hart, he's actually dead since, R.I.P. Brian, some man, that the anodized coating wore, you know. It was extreme conditions, as I said, you know. But you can also see the air holes there as well that feed. It's similar to the Cosworth head, and again the drilling along here that fed the air holes. Now, the one thing with the drillings here, when you're casting a something like a cylinder head, a complex shape like that. The rule is with casting, if you can help it, you don't mix thick sections and thin sections, because what happens is the thick section will cool last, and when that happens, it tries to suck. When it cools, it shrinks, and it'll try and suck material from the thin sections. So what happens is, if these have solidified, it obviously can't suck material from there, so it'll actually just crack, and it'll stretch crack, if you want, contraction cracks, I guess we can call them. So they were brave putting a drilling through. That's quite a heavy area there, there could be a lot of porosity there. Now, you could polish it if you wanted to and get in there with a magnifying glass to check for porosity, but normally in conditions where you're drilling a heavy area in a casting, you would line it like, with like a hypodermic tube, that would get rid of that issue. I think it was a big problem early on before the cos cast cylinder heads came along, where the porosity was, causing them to leak oil. I can't remember exactly what happened, but I think they were leaking oil into the waterways or something like that through the heavy areas that had porosity. But that's what happened there, But obviously it worked anyway, But it was some length of a drilling as well, because the cylinder heads, I think, were 600 mil long. So that's some drilling, like, it's not a core, it's an actual drill way. So that was fairly tense for the machinist, I'd say. Is there anything else worth mentioning on this? Again, this had hollow camshafts, they're oiled. These were oiled from the top journals, and it just sprayed out there. That's elementary enough stuff. But yeah, that was the Brian Hart head. So, I mean, in fairness, at the time it was amazing. It also had the compound valve angles. They were splayed in both directions, where the Cosworth hasn't. It's just splayed off the vertical, whereas this was splayed both ways, which made fairly interesting cam lobe angles. So I wouldn't pity that cam grinder's job. But again, it was of its time. It was a very nice casting. So that's enough of the Brian Hart head. We'll be back to the Cosworth one here again. So what I'm going to do is I'm going to strip this down. It's, again, very simple. So as you would in a normal engine, you'd normally have I guess a collet pliers, or a valve spring compressor, or a drill press, depending on how stuck you are. But if I just press that plunger down, so that's the plunger down, and the collets should come out now. That's one. That's the second one. And I'm going to take off the lash cap. So I'll just leave those there. I'll just give you a close look at those. Hopefully it focuses. They're nothing special, they're single groove. They're very light. I would imagine they're steel, or some sort of very good steel. I'm not going to go into specs because there's too many. So you can see there then, that's what it looks like. Pretty basic so far. Now what I'm going to do now is pull out the valve, so I can push that down all the way and just remove the valve like that. Now the valve is very light. If you've never seen a Formula 1 valve, every valve you've ever seen after this will look like something out of a tractor or the Titanic. I'm not sure if that had valves, but I don't think it had. But it's extremely thin, and it's wasted down then to, I think, 4.3 millimeters. So yeah, they're extremely light, and a nice item. You can see that's the CA valve there. You can maybe see it on the front there. CA there somewhere on the left hand side. Again, you can see the ring for the lash cap. You can probably see it there. So that's the valve. Nice item. It also has there's probably a technical name, what I'd call it, a turbulence groove, just on the face. See the ring around there. Without getting into aerodynamics and all that craziness to do with cylinder head porting, we'll leave that for another day. It just creates turbulence at low lift. So that's what that ring does. It's very slight, maybe 0.3 mil high and maybe a millimeter wide. So they're quite big valves. They're, I think, 40 mil diameter or something like that. Yeah, that's the valve. Standard enough, nothing too crazy about that. We'll leave that there for the moment. So, removing this, I'll just push the plunger out of the way. We'll leave that there for a moment. And that, and that. So, the body is hollow. They've machined it from aluminium. It's probably 7 series, I would imagine, or 7 or 2 series, probably 7. Aerospace aluminium, as they call it on the internet. Although I think that's probably 6 series that are getting sold. But anyway, so it's a nice part. It's probably a 5-axis part. There's a lot of machine work, and there doesn't seem to be any interruption. So I would imagine it's probably done all in the one fixture, on a 5-axis. Looking at it, on the bottom, where the valve comes through, this is its own valve guide, by the way, a tiny item. You can just see it there. I've it pressed in. I actually got that as well with the system. So I pressed that in there. So it's its own valve seat or valve guide, so to say. So that's normal enough. So this ring, there's actually an O-ring missing out of this. I should have brought it. I forgot. There's a very small O-ring that goes around the outside of that. So that seals down there like so, and this then would seal on top of it, and the O-ring would seal both. So if I remove that and put it in here, you'll see where the O-ring groove is. So you can see where the O-ring groove is on the outside. On the inside, there's a seal. It's a spring energized PTFE graphite filled seal. Now it's not unlike something off the shelf from Parker Hannifin or someone like that. There's nothing too special about that, from feeling it, and from I had spare seals, and from burning it and all that and analyzing it, it's like it's doped with graphite, probably, I don't know, 25-30%, and it's just interference fit in there, and that's that seal. So that's the main air seal on the bottom. So if you shove that on there, that's your air seal. So that's one seal. All right. So I'll take that off for a moment. So you can see the air entry port here. It comes in from the banjo fitting, and it's drilled down into the cross drilling, and that enters here on this side here. And there again, there's a small little O-ring in there. Hopefully that focuses. Should do. And the air enters into the main body. Now again, there's cross drillings and all that on this. There's a lot of stuff going on in here, which I'll speak about again. There's pressure release valves and pressure valves and all that for the entry pressure. But just to see how it works, or what it looks like, should I say, it's a basic enough part. So the air enters then in here. Hopefully you can see that. There's a very small hole just on the inside there where the air enters the chamber. So that controls, obviously, that's the main pressure. And again, there's a second hole. There's an air entry and an air exit, or an oil exit, because when it fills up, you can see the entry is higher up, and the exit is there. I might have got them wrong a minute ago, but basically it can purge the oil out, and it blasts it away out this hole here, and it keeps everything in check. Now, getting back to the Brian Hart system for a moment, I said it was just an aluminium cylinder, and with the PTFE impregnated anodize, they went for a different route here, which it's somewhat surprising. Now, I read a magazine article on this engine a while back, the CA engine. I can't remember who's done by. I won't name them, but I honestly can't remember. And I knew there was something amiss, because number one, I knew Cosworth wouldn't give him all the parts for the photo shoot, because these have never been seen before. And when I looked into the bore, it just seemed a bit irregular. Now you'll see why I spotted that in a moment, and why I knew it wasn't the whole truth. There's actually a steel liner in the aluminium part in this. Now I'll take it apart and I'll show you that. The steel liner is very, very thin. It's shoved in, and it's held on with a top hat, which is then bolted down through so it holds everything. So if I take off this top hat now, I'll just twist it off. Hopefully it should come off. So there's the top hat that holds the liner in. It's a titanium part, and it's pretty simple but vitally important. So I'll leave it there for the moment. Now you can see the step on the liner, that it keeps the liner down, you know. Now I guess they went to this for many reasons. You know, surface finishing is a bit more well understood with steel, with tool seals and all that. It's pretty bulletproof, you know. You can also do, you can probably see, I don't know if you can or not, you can see there's like a cross hatching on it. It's hard to see. You may be able to see when I remove it, but there's a cross hatch on it, so you can, you know, you can feed the seal with enough oil or as much oil as you want, depending on how deep your cross hatching is and all that, like a cylinder bore. But this then is pressed in. Now hopefully it should remove with a bit of force. It's in with a very slight O-ring. So that's the liner. Again, it's very thin. I'm guessing by feel about 0.6 mil, 0.5 mil. It's a bit of a chamfer there to guide it in. And the reason there's a chamfer there is because there is another O-ring there that seals it into the aluminium part, which you can see there. Now in the magazine article, when I looked at it, that's what I was looking at. And I thought to myself, hang on a second, how is this going to slide, you know, up and down there and past a seal and all that? And it just didn't make a lot of sense. So I knew it wasn't the whole picture. So there might have been a few secret spies or readers fooled with that article. But I'm glad I found out there was a liner, you know, so that we all know now. But that's kind of that part. Yeah, it's a nice part, you know. Again, there's well, in the V8, you know, there isn't as many seals, but you know, a V10 you can multiply, like there's 1, 2, there's 3 on the piston, 4 on the top stem, 5 here, you know, it's 50 seals that all have to seal straight away, you know, without any of the ancillary seals on all the other air supply stuff, you know. You can see there again, it's stamped. You may be able to see it, CA. My lighting isn't great, but it's there on the side. So that's that. Now, the most important part, which you and I will call the retainer, I guess. Now this also has a seal on it, obviously, for sealing in the liner, which fits in there nicely. Again, this part is aluminium, 2 or 7 series. It's a spring energized seal. Now, looking at the Parker Hannifin catalogue, at first glance, it looks the same as an off-the-shelf seal. You can see this cross-section of the seal there, should be there on your screen. But I noticed with this, it's got very slight, and they appear to be machined afterwards, post-machined. It's got very slight divots here. I don't know if you can see that, just along the perimeter on the top. Now I'm guessing that's to let in a small bit of oil down into the, I guess, the secondary seal, so that it just keeps it happy. So that's that seal, you know. Nothing mind-bogglingly crazy or anything like that. Just a normal enough looking seal, you know. You may see one like it in a Festo pneumatic ram or something like that, but nothing out of the ordinary. And again, on the inside, there's just an O-ring and a groove there, just standard machinery handbook O-ring spec groove and an O-ring, which seals the stem of the valve, which again is a high pressure air seal, you know. So that was, I remember when I saw this first, it was like amazing to see all these seals and how they did it, and it was like, my God, it's amazing, but yet it's so simple when you actually see it. But of course, it's not simple at all. There'd be hundreds of thousands of pounds of development behind all this, you know, for many years with many engineers. But hats off to them. So that's that part. Now what I may do is just pause you for a moment and grab an Allen key and pull out this and have a look what's in there. So I'll talk to you in a sec. So I got the release valve loosened. Careful not to lose anything out of this now, it's quite small. Just push those over there for a second. This should just tap out. So the release valve, as you can see, is a spring. It's held in with this little set screw, which is keeps that under pressure, you know. Now the tip of the plunger, it's like a silicon bronze or aluminium bronze or whatever you want to call it, and it's got a ball bearing then pushed into the top, just so that it doesn't erode, anything like that. There's also, which you won't be able to see, I suspect, may come out. No, that's going to stay in there. There's a very small little bronze seat as well in there that the ball bearing sits against. Just again for, you know, this would hammer on that at times, you know, so that it doesn't erode it away. So it's just got to be a bit durable in there. So that's how that works. It's pretty simple, you know. It's just a simple pressure release valve. The venting actually happens as well through this. I'll explain that. Well, actually, probably the best thing you could do is log on to F1 Technical and read the full write-up, because there's some parts I'm going to miss in this, or they're just going to be too boring to go through, which are all in the article. It's not a plug for an article. It's just, if you're interested, go on there. It's called I think it's called Pneumatic Valve Assembly, a closer look or something like that. You'll find it. So that's how that works. Now there's another one in here as well, which I'm not going to open. It's the same thing, but it's in with Loctite. You can see the grub screw there on the top, which is the feed in. So that lets in the air if it's too low, and if it's too high, this one lets it out. So it's pretty simple, you know. So that's how that works. So if we take a look at, I took an impression of the TJ cylinder head. It'll just give you a rough idea of what that looks like, what the ports look like and all that, you know. The spark plug location, where this would all sit. I'll just assemble it briefly. Well, yeah, I can assemble it, yeah. Just very quickly, just to give you an idea of how it'll all go together. That will go in there. This would feed in here. My plunger is here. Actually, I put it together this way. Like so. That will go in there. I have to put it together this way upside down, because the valve stems don't go all the way through the silicon model. So it would sit like that. When it's in the engine, it'd just sit above it. The valve guide is quite short, so in the engine it'd be like that, you know. This is the intake side, so it'll be canted over it, you know, 45 degrees or 90 degrees depending on how you're looking at it. But it would sit there pretty happy this way. And again, these all drain down. Where these exit here, they drain out, you know. So that's how that would sit. And again, the finger follower would be above the valve here and all that. Actually, I must lay out the finger follower just so that you see it, just before we call this video to an end. That would be like that. This is a section of camshaft from the TJ that I cut. I had spare camshafts, so I cut up one into sections just to display it a bit nicer. There's some amount of duration, some amount of lift as well. If you can see the base radius compared to the lift, you know, it's quite enormous. So this would go in here like that. That would bolt to the cylinder head. It would sit there. So what am I doing? So it would all sit like that. And that's pretty much it. So that is how that assembly looks like, how it works, how it goes together. Um, Again, never been seen before. It was an amazing surprise for me to take it all apart, to, I guess, get my hands on it first, um, and to show it to whoever is interested, I guess. Um, I know I remember when I launched the article on it, um, it got a huge amount of traction. I was getting an awful lot of messages about it and all that, from everyone from students to engineers and all that. Um, so it was very exciting, and hopefully we'll see the return of high-speed engines again, but we may not, um, with the new turbos and all that. Hopefully it never goes electric fully, but that's that. So stay tuned for more videos on this. I'll probably do one on. I think I'll do one on torsional vibrations on the valve train, in say another week or something like that, every other week. Um, with the dampers and all that on the gear train up to the head. So that's going to be fairly interesting. Just one last thing before I finish up, to compare the heights of the cylinder head, which it's not a great comparison, but it'll give you an idea, of just the sizes and all that. You can see they really made it small. So yeah, that's that. Thanks for watching, and give it a like, give it a share, send it to whoever you think, or just lie back and listen. Take care, folks.